All right. We've already said that an appropriate model will have a residual plot that meets these requirements. And by the way, pay attention to these. Residuals must be random, without pattern, and centered about 0. All right, so the residuals must be random, without pattern, and centered around 0. And the variance of the residuals must be consistent. This is kind of something new for College Board. All right, they're specifically wanting to know that, and something we're going to get to need to add to our note spiral. So the variance of the residuals must be consistent. In other words, you shouldn't see data getting farther and farther away from the plotted line, nor should you see it getting closer and closer to the line. So the variance along the line, if my prediction line looks like this, I should have data equal distance about it. I should not start off with this and then be growing and growing and growing and growing. That would be my variance. I would violate the variation rule. Okay. So next thing, they like to throw ugly stuff every now and then, and we really don't talk about logs. And quite frankly, I'm not being a real math guy, so I'm not a big fan of logs to begin with. But they like to put logs on questions. You're like, well, I'm not a math person, that's why I took stats, and logs scare me. And I said, that's all they're trying to do is scare you. Okay, that's their goal. So when I look at this, it says 2 measures X and Y were taken and 18 subjects. The first of 2 regressions. Regression 1 yielded this equation and had that residual plot. Regression 2 yielded this one. Well, not knowing anything about logs, but knowing what I know about residuals, I see a definite pattern there. Because I see a pattern there, I don't like that equation. I don't like regression 1. When I look at this, I'm a little concerned about the density, but I'm still seeing a lot of randomness. So because I'm seeing randomness, this for sure is a better equation. You're like, but Mr. Spencer, that's horrible. It has logs, all right? This one up here at least didn't have logs, Mr. Spencer. This one has logs, and you told me we don't like logs. And I'm like, yeah, I know, but we like this residual graph. So we like this graph better. So consequently, I'm looking at the multiple choice, I'm going, you know what? That means I like regression 2 better. That means regression 2 yields a better fit, regression 2 yields a better fit. So that gets rid of A, that gets rid of C, and that gets rid of D. So, really big question to you. There is a linear relationship between X and Y. No. There's a linear relationship between log Y and log X. Because this tells me, hey, this model gives a linear relationship. But it gives a linear relationship between log Y and log X. And you go, well, what about this X and Y bit? We graphed it up here. It was totally nonlinear, all right? So at this point, there is a nonlinear relationship between X and Y, all right? There is a log relationship between X and Y, all right? Does that? And then I'll come back to that in just a moment because I almost finished with what I have to say. Couple other brief points of things to know. Know what a correlation of 1 and -1 looks like. 1 means it's a straight line, like that, all the points on the line. -1, straight line, down, all the points there. This is +1, this is -1. And then a relation of 0 can be anything that's not linear, all right? A relationship of 0 would be anything that's not linear. Next thing. A slope of 0 is not useful prediction, and horizontal lines have slopes of 0. And that's basically, and you're like, well, how come it's not useful? Well, because regardless what X is, Y isn't changing. So a horizontal line is not useful for prediction. I would highly recommend you review segmented bar charts, but they're built into your AP your AP problems and review contingency tables. They're also built into your AP classroom, but there's also describing data def packet. So the previous def packet problems 1 through 8 if you're looking for quick review. Okay.